So hi everyone, today we are gonna discuss problem number 3 from build understanding part. Okay, let's continue. So one announcement that a free course of J Advanced and IN Pincher batch for 2026 has started, and you can join it for free. You can just check your orientation video in my channel. Okay, then there you can search Telegram channel of mine. Okay, then you can join it. So let's start the question, which is your build understanding part, kinematic section, and Pathfinder. Okay. So first, it's saying there's a narrow bridge somewhere on a road connecting two towns. All right. Two car travels from one of the towns to the other with a constant speed v1 everywhere on the road except on the bridge. Okay. So it's saying that we have two towns. Okay, and we have a bridge in the middle, and the bridge is connected by two roads which are either left or right. Okay, left and right of the bridge. Okay, wait, let me just help you by making a clean diagram which will help you in understanding the question, what the language of question is. See, it's saying that we have town number 1, town number 2, and this is a road. Okay, not a bridge, and this is a bridge, and this is again a road. It's saying that it's saying that two cars, okay, two cars have v1 velocity in the road, v2 velocity in the bridge, and again v1 velocity here. Okay, so by analyzing this separation versus time graph, this is separation versus time graph, not ST graph. Okay, so by analyzing this separation versus time graph, we can directly conclude to the answers. Okay, so we can just directly tell the answer. Okay? So first let's analyze something part. Okay, so if I clearly see, okay, just focus on what I'm trying to say. Okay, if I know that if this and this is moving with v1 and this is also moving with v1, okay, so the separation between them, if I say s, so s will neither increase nor decrease. How am I telling this? Okay, so let's say that this both particles are traveling in the same direction with v1 meter per second. So if I say ki what's the distance traveled by both of the particles in 1 second, you will say v1, and again this is v1. Okay, so if we say that the separation between them doesn't change, okay, the separation between them is same which was earlier. Okay, but in this graph, if you see, for 10 seconds we have 500 separation, but after 10 seconds we are seeing that the separation between two cars are getting decreased. All right, so by this we can say that the first car which was moving ahead of the second car has reached the bridge at t equals to 10 seconds. Okay, first conclusion, we can say that your first car has reached the bridge at t equals to 10 seconds. All right, and at t equals to 30 seconds we can see that the separation is again being constant. Okay, so if we say that both cars have reached on the bridge, okay, so then again their separation will be constant. How I'm saying this, again with the same concept, okay, that v2 meter per second and v2 meter per second, right? And again it's getting increased now. So now we can say that your first car has crossed the bridge and second car is crossing the bridge. Okay, and again from here we can say that both of the car has crossed the bridge. Okay, so by this thing we can just conclude to the answer. Okay, so this is very easy problem from Pathfinder, right? So I say that this is your bridge. Okay, I'm just zooming this part. Okay, just focus on this part, this part. All right, so I'm just focusing on this part which was your road, and this here was a bridge, starting of the bridge. Okay, so if I say that initial position of a second car and initial position of first car, so we have, so this is given in question that initial separation between them is 500 meters. So I can directly say that initial separation between them is 500 meters. Okay, and if I let this as x, okay, so we are given that the first car just reached the bridge at equals to 10 seconds. Okay, so I can write the equation directly. So v1 into t is equals to x. All right, this is our first equation, and with this is 500 plus x is our distance, and which will be equal to v1 into, again, how much time second car took, which is 30 seconds. So okay, so I can write x as 10 v1 equals to 30 v1. So I can write it like this. So I can write it like your v1 is equals to your 25 meter per second, and this is our correct answer. So let's move to part number 2. Okay, so it's saying what is the speed v2 of the cars on the bridge. Okay, so for this I have to come to the bridge. Just listen me carefully. Okay, let's say your second car has just reached the bridge. Okay, your second car has just reached the bridge. Okay, so we have given the separation when your second car just reached the bridge. Okay, here we have given the separation is 200 meter. Okay, but we know that your first car has traveled a distance of your 30 minus 10, which is 20 seconds. Okay, 20 seconds in the bridge with the velocity v2. So I can say that your second car is here, and this distance should be equals to a 20 v2, but the separation is given as the separation between them is given as 200. All right, so we can directly say that 20 v2 is equal to 200. Okay, so I can directly say that your v2 is equal to 10 meter per second, and your second part is also done. And by your third part, all right, if you see at the third part, it's they have asked what is the length of the bridge. Okay, so we know the velocity of a particular car on the bridge, okay, which is 10 meter per second square, and for how much time does any of the car has traveled in on the bridge. Okay, so we can see that your first car started the bridge here and ended the bridge here, so 80 minus 10 is your 70. So I can directly say that this is your 700 meters. So this was your solution, and it's very easy problem if you know the proper analysis of graphs. Okay, so this is also done. So this is your 25, I guess. This is your 100 something, and this is your 700 something. Okay, so this is my answer, and I hope you all have understood the concept and the question. Okay, so let's end this session, and let's end this class here. Okay, so I'll meet you in next class. Okay, bye bye, radhe radhe.